Welcome to Sweet Life Beat Life. We hope this video helps.
You start by preparing data and defining a simple network. Load your labeled dataset, then normalize inputs so training converges faster. Next, split into train, validation, and test sets. This prevents overfitting. Define a small model. Input layer, one hidden layer with 32,128 neurons, re-LU activation, and an output layer matching your labels. Use a simple loss like cross-entropy for classification or mean squared error for regression. Once done, choose an optimizer such as Atom with a 0. 0.0.1 learning rate to begin training. You now run training and keep a close watch on metrics. Train in minibatches and validate after each epoch so you catch divergence early. If validation loss rises, reduce learning rate or add dropout 0. 2.0. 5 to the hidden layer. Log training and validation accuracy or loss to visualize trends. This helps you decide when to stop. Once you see stable validation improvement, save the best model checkpoint. Make sure to reevaluate with the test, set for an unbiased performance estimate. You finish by exporting and validating the trained model for deployment. Convert to a portable format and run it on unseen examples to confirm behavior matches your test results. If predictions are poor in production, first reproduce the issue locally. Check for mismatched normalization, data schema changes, or class imbalance. If training fails to converge, try simpler architecture, lower learning rate, or more data augmentation. One key troubleshooting tip: always verify your preprocessing pipeline is identical.
Thanks for watching. Consider subscribing if we helped you.